Bar freshness, I be on my Excel. Claim they hard, they be Microsoft Excel.
Today, I want to talk about t-tests. And t-tests are used to tell if a mean between two groups is different. So look, here's our first group here. I look over here. We have these 20 students. I changed their names. That makes it a little bit wider. Right? They have 20 different first names. And they took a test 1, and then they took a test 2. And we want to ask if the two means are different. So let's see if we can do this. So the first thing I would do is I'd figure out their average and then the standard deviation. So I'd go up here, equals average, highlight these, close, right, and the first average was 84.5. You can drag it over. It went up to 89.9. But the question is that statistically significant? Is that difference statistically significant? Next, we could do the standard deviation, see how that looks. So we get an idea of how much spread there is. Right, that one goes from 9. And this is 5. So it's actually there's more spread in the first exam. So so it's like the grades went up and they were more uniform. But is that difference significant? But I want to show you a trick before we begin. Imagine all these first and last names. You want to split out the first names. You can split this column by the commas. So I'm going to highlight this, right? And then you can do data, text to columns. You can do delimited, hit next. You say usually it sits tab, but usually you click on the comma, right? Because it's going to split at the comma, hit next, hit finish. It's going to replace it. So I'm going to hit cancel, right? Because it's adding us a new one. So I'm going to here, go back here. I'm going to insert a column. Now I'm going to go back, do data, text to columns, next, comma, next. It's going to look finish. And now look, we have last name. Do we need to split last name, first name, right? And then we can move this over. We have our averages, the standard deviation. I'm going to put a little underline here to make it look nicer. Bottom border, I'll do it. Bottom border up here. This looks nicer. Now we're ready. So for our 20 students, is there a difference in their test scores? Is this significantly different? So I'm going to do a t-test. Whenever you have two groups you want to compare, you do a t-test. So in Excel, you do equals t-test, hit return. Oh, I always hit. You click on here, equals t-test. Right, and it tells you what you want to do. And if you click on here, the help comes up and it tells you what you want to do. The first thing you do is you do array 1 and array 2, what you want to compare. And this is array 1, comma, array 2. This is what we're comparing. Now it wants tails. And tails is a little funny. I'm sort of telling you about the how it's distributed. I always do two-tailed because it makes it a little bit statistically harder to achieve if things are going on. So I'm going to do comma 2, comma 2. Now this is the tough one, type. So with this one is paired, because see what happens is we have each student is taking a test 1 and then test 2. So you know each test goes with the same student. Therefore it's paired. The two tests are paired to the same student. So we are going to do paired. Then you close it and hit return. And then you look, this gives you a p-value, right? And we already talked about p-values a little bit. So you want a p-value that's either, depending on how you're working, is less than 0.05 or 0.01, because that tells you the chance of it happening randomly. So look, this p-value is 0.001. So that means it has, a 0.15% chance of happening randomly. So you would say these averages are different. You give the averages, and then you could say p at the less than 0.01 level. So be pretty confident to say that the test scores increased from the first test to the second test. So that's exciting for this class. This class is improving and getting better. So now let's go look at some other test scores. Here's something for test 1 and class 1 and class 2. So we don't know these students now. We just know there's a class 1 and there's a class 2, and there's a different number of people in these classes. So now we want to ask the same question. How do these test scores look? So again, the first thing I would do is I'm going to figure out the average. I'm going to figure out the standard dev. I'm going to go put it in. Equals average. What I'm going to do is I'm actually going to grab all these, and you'll see in a second. Right, grab all of them. Oh, and I misspell average at least once a day in Excel. A-V-E-R-A-G-E. There you go. And that equals S-T-D-E-V. You can grab them all again. Right, and it goes, it went from 85.8, we're going to drag it across to 90.3. I'm going to give it an underline here to make it nicer. Same here, make it nicer. Right, and so now it looks like this average went up from 85.8 to 90.3, but we want to know, is this statistically significant? Did this really change? And if you ever want to change, a quick way to change your decimal places by using these two numbers up here. See, no, you want more than, I think for this, right, I think we want 1 decimal place is the way to go. So now we're going to do our t-test again. So equals t-test, right, and then, right, you do array 1, comma, array 2, comma. I'm going to do a two-tailed distribution, comma. And now here's, it's not paired, so we're not going to do paired. And usually what I do is, the most conservative way to go is 2 sample unequal variance. That means you're not sure if the variances are equal, right? And so this is what I would do, 3. Right, and then you look at this, oh man, 0.08. So this is not a significant difference, right? So you cannot say that the mean is different between these two classes. Even though it looks like it, you'd initially look at these averages and you say, oh, class 2 is higher, but you cannot say that because when you look at the t-test, you cannot say they're significantly different. So you can say class 1 had an average of this, 85.8, class 2 had an average of 90.3, but there was no significant difference at the p less than 0.05 level. So that's it for t-test. If you remember those couple tricks for when to pair, when not to pair them, how to run it, you can now start to say if things are significantly different. And whenever you have 2 groups, you should always run a t-test. Good luck.